Hello everyone. I am Sayyida Nikat Fatima, working as an assistant professor in Department of Civil Engineering, HMSIT, India. I am here to present my research work on a study to check the effectiveness of software and to analyze a 15-story or C-framed structure using tuned mass dampers. So the today's contents are as follows. Before I introduce my topic, I would like to introduce why I have selected this topic. So I have selected this topic because there are some vibrations which are occurred on a structure majorly due to a wind load or a seismic load. So due to such vibrations, there may be a damage to a structure. The structure may also get collapse. We can see the cracks on a structure. So in order to control such consequences which are occurring due to such vibrations, a unique technique has been introduced and the technique is named as tuned mass dampers. So I am in my I am working on the tuned mass dampers and I am being introduced those tuned mass dampers in a building structure in order to control the structure from such vibrations. So the object is what I have said during my study is I am firstly checking the effectiveness of SAP software by comparing the results along with the manual results. Then onwards, I am going to evaluate the systematic as well as the structural response which are coming from a 15-story RC framework structure. Here, five different models has been analyzed. The very first model is analyzed with the fixed base structure. Then onwards, a 15-story structure with a tuned mass damper of mass ratio 2% has been analyzed, and then onwards again a 15-story structure with a mass ratio of 3% of tuned mass dampers is being analyzed. Similarly, the fourth structure is again a 15-story structure with a mass ratio of 4% of a tuned mass damper is being analyzed. Finally, a 15-story building structure with a soft story at its top is being analyzed. I am analyzing five different models and the results of those five different models has been compiled to check which model gives you the best results. So the methodology what I have followed during my study is firstly I calculated the forces which are coming over a structure manually. Then onwards the same forces is being calculated with the help of a software named as SAP 2000 by considering a 3-day model of G plus 3, and then a tuned mass dampers of five different models has been analyzed with the same software called SAP, and by during the analysis I am considering a non-linear time history analysis for my work. So in order to check the effectiveness of software and for the manual calculation, I have considered this data. So I am considering a type of structure as OMRF, which has a G plus 3 stories with a high floor height of 3 meter, and a structure is basically used as a commercial type which has a material properties of M20 grade concrete and Fe500 steel with a Young's modulus of 25 into 10 raised to 6 kilonewton per meter square and has a Poisson's ratio of 0.2 with a slab thickness of 150 and column and beam sizes of 230 by 450 mm and with a wall thickness of 230 mm. And let us consider a live load which is coming over a structure of 4 kilonewton per meter square with a floor finish of 1 kilonewton per meter square. And let us assuming the structure is located in a zone 5 of Gujarat in Bhuj, and then the soil type I am being considering it as medium type with a concrete density of 254 kilonewton per meter cube and a density of mortar as 20.45 with a brick density of 18. So firstly I am calculating manually, so for which I got a weight of roof along with the vibration as 2000 to 65.9 kilonewton. And then onwards, the individual flows weight has been calculated, and those weights are 2006 11.563. So I am here adopting a equivalent static load method to for my calculation. So then onwards, I got a fundamental natural frequency of 0.528 second with a horizontal lateral pressure of 0.225. And finally, I got a base shear value of 2272.632 kilonewton. So now this base shear value is being compared with the base shear value what I am adopting, or what the model what I have prepared with the help of SAP software. So in order to analyze a building in a SAP software, I have followed this procedure. So firstly, we need to open the software obviously, and then onwards we had to set the units, whether we are setting it in the MKS system or in SI system. Then onwards we had to define the material property, and those materials are concrete and steel. And then onwards we had to define the members properties in it. So those members are wall, beam, column and slabs. Once once the material and the members has been defined, we have to assign those materials along with the load cases. So here I am considering the default load case because I am only checking the effectiveness of software here. Once everything is done, finally we had to run the software, and whatever the result that we get from the time history nonlinear analysis, that result is being compared with manual results. So here are the result what we have got. From manual calculation, we got a result of 2272.63 as our base shear, which is in terms of kilonewton. Similarly, we got the same value of almost similar value of which is being analyzed with the help of the software, which is of 2278. So we can finally conclude that our software gives somewhat better results, and it also reduces the time period. So next, the second part of my work is to analyze a 15-story building. So this is the model of 15-story building in a SAP software. So here I am introducing the TMD at the top story at every junction of beam and column. So then after introducing it, finally the results what I have got is, see, the lateral displacement result is being distributed like this. So in this chart we can say that the soft story, if we introduce soft story at the top, it gives somewhat better result compared to the rest of the stories, such as it may be the rest of the models, such as it may be a fixed model, or if we introduce a TMD with a mass ratio of 2% or 3%. But if we introduce TMD of 4%, it gives somewhat better result compared to the soft story. Similarly, if we check the variation of the story drift within a building of 15 story, we came to know that TMD of 4% gives the better result compared to rest of the models. Similarly, the variation of roof displacement also, here also the TMD of 4% gives you the maximum roof displacement value compared to other models. Again, the same case, a variation of acceleration at the base gives you the better results if we introduce TMD of a mass ratio of 4% compared to other rest of the models. Coming to the axial force, we can see the maximum axial force is occurring in the soft story building, which is quite uh, 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 which don't have to be, we cannot go with the maximum value of axial force because there may be a chances of damaging the structure if we get the maximum value. So hence the soft story we cannot adopt it, but we can introduce a TMD of mass ratio of 4% in order to reduce such axial forces which are coming over the structure. Coming to the variation of bending moment, we can see that the maximum bending moment is being occurred for the soft story, 2 unit mass dampers with 4% of mass ratio compared to rest of the models. But we are getting the least value of bending moment value in the soft story building. Again, it is a drawback if we introduce a soft story building at the top. Then coming to the way variation of the shear force part. Here, the soft story, we can see the soft story at the top gives you the maximum result compared to the other models. Again, it is a drawback. We cannot go with the soft story because we don't want the maximum shear force value come on our building structure. But the TMD of 4% gives you the very less value of shear force, hence we can adopt this. So finally, from the result, I can conclude that from the comparison of the manual calculation along with the software calculation, we came to know that our software gives a better result and the accurate result, and at the same time, it also minimizes the time. And then the lateral displacement is more in the fixed base. In order to control such displacement, we can make sure that if we introduce a tuned mass damper of mass ratio of 4%, that TMD can reduces or it gives you the least result of lateral displacement compared to any other mass proportions. Similarly, TMD of 4% gives you the less value of story drift compared to the other mass ratios. Again, TMD of 4% also reduces the roof story or rooftop displacement which are occurring at the top floor of the building structure. And then comparing to the axial forces, bending moment, and the shear forces, apart from all those three, we can conclude that TMD of mass ratio of 4% is much suitable in it to adopt for a building structure, any type of structure, so that it can reduce the maximum amount of vibrations which are coming over it. And these are all some of the references what I have made during my study. So thank you.